All right, and finally, the conclusion of this lecture. And so we have seen these neural networks, and neural networks are a type of a parametric machine learning model. So they make their prediction by forward propagation, which is essentially a stream of matrix multiplications and nonlinear activation functions. Then these neural networks, so they are, again, parametric models. So they are trained by some optimized version of gradient descent, so which keeps updating these parameter values until it reaches a minimum of a loss function. And this update rule for the gradient is called backpropagation. So we did not cover it in the lecture, and I did not teach you how to actually calculate the gradient of the loss function, and simply because it is conceptually it is easy, and again it boils down to matrix multiplication, but at the same time it is very tedious. So there is a lot of matrix multiplication. It's very easy to make a mistake if you do it by hand, and it is very hard to implement it correctly in R on Python. But you know, some other people have already done it for us. So Google engineers have made this library called TensorFlow, and a lot of other deep learning libraries sit on top of TensorFlow. So you don't really have to think too much about it unless you're going to do research in deep learning, right? So in practice, so you just need to have some understanding of you know, what's going on there. And I hope that this lecture is more or less sufficient to gain this basic understanding. So to train a neural network, we need to make a lot of choices, and that there is a lot of hyperparameters that I need to define. Well, and some of the choices here are not up to us, so they are actually determined by the type of machine learning problem, and these are activation function in the last layer and the loss function. So the rest of this, the number of layers, layer dimensions, learning rate, weight decay, dropout rate, so the type of regularizer, so the type of optimizer, and so on and so forth. So they are kind of, so some of them are better, some of them are worse, but it is impossible to say in advance what the best choice is going to be. So you've got to try and to play around with different choices, and this is what makes artificial neural networks kind of hard to work with. I mean, it takes a lot of time to fine-tune these hyperparameters, right? So in practice, you know, if you have a very large data set and a very highly dimensional data set, then an artificial neural network is going to really work better than any other type of a machine learning algorithm. But for small data sets, is not really, there is no much of an advantage here, and probably usually it's better to go with a random forest or support vector machine. And here is the checklist of concepts for today's lecture. So, and that's the end. Thank you for your attention.